Okay, YouTube, in this video we're going to talk about matrix equality, and as a quick review before we talk about equal matrices, let's talk about what a matrix is. Remember, a matrix, we usually use uppercase letter to denote that something is a matrix, and we also could represent a matrix here. So we have matrix A is in brackets some lowercase aij, and I do want to write this out here. What we're saying is this little a here is in matrix capital A, and by the way, it is in the ith row and the jth column. So what these I and j subscripts are kind of telling you what entry it is in this matrix. And the last thing I want to note here is this: the order of this matrix is the number of rows and columns total. So we say it has m rows and n columns. Okay. So when we talk about some aij, we're saying that this is in the ith row and jth column. Kind of what we're saying here is this: I is some number between 1 and m. Okay. So in other words, when we say that something is an ith row and jth column, we say that I is some number between the first row and the last row, which the last row is the mth row. Okay. When we say jth column, we say j is some number between 1 and n, where n is the number of columns. So we have n columns. This is the nth column right here. And we say that j is some number between the first column and the nth column, so that's what we're kind of restricting it to here. But basically, if we had two matrices, we say A and B, if they were equal, one thing can be said about them. First of all, they'd have to have the same order because they're the same person, so they have to have the same number of entries in each. And we say they're equal if and only if they have the same order and all aij's equal all bij's for all of these i's and j's. So essentially what we're saying here is this. And we can take a look at this example down here. It says the following matrices are equal. Solve for any unknowns. I'd say these two matrices are equal if and only if, first of all, they have the same order. I notice that they both have 2 rows and 2 columns. So 2 rows, 2 columns. And I say, well, if these are equal, then things in the same spots would have to be equal. That is, if this were some matrix A 2 by 2, and we were saying this is equal to some matrix B 2 by 2, then I would say that A11 has to be equal to B11. And I'm talking about lowercase. So what this means is this x right here has to be the same thing as this 7. So if I were solving for unknowns, I could start by saying, well, then x would have to be the same as 7 because they're in the same spots. Likewise, we say this 3y minus 1 is the entire entry right here in the first row, second column. That is, our first row, second column has to be equal to the first row, second column of the second matrix. So we'd say that in this case, we get the conclusion 3y minus 1 is equal to 8. And then we could just basically just go back and solve for any unknowns here. So we say 3y is equal to 9 and divide both sides by 3. We would get y equals 3. So we would say y must be 3. And then last but not least, we say that this z right here, this is a z. Z has to be the same thing as negative 10 just because they occupy the same spaces and by definition of equality of matrices. So have to have the same order and corresponding entries are equal to one another if they are equal. Cheers.